Okay, today's lesson will be on projectile motion, actually covering some different problems using projectile motion concepts. So here we go. All right, let's look at the idea of an airplane that's traveling horizontally at 115 meters per second. It drops a package from an altitude of 1,050 meters. Determine the time required for the care package to hit the ground. Okay. Now, from our understanding of projectile motion, you can see that the horizontal has nothing at all to do with the time it takes to fall. Also, in the previous video, we talked about the shape of a projectile motion being a parabola, or a part of a parabola, and you can see here that it's part of a parabola, not the whole parabola. So this horizontal motion of 115 meters per second has nothing at all to do with the time it takes to hit the ground. All right. So all we're going to be dealing with is the information in the y direction. We're going to count up as being positive and down as being negative. We could have actually changed that and had all positive numbers if we wanted to. All right, so we know that the distance down will be 1,050 meters. The acceleration is negative 9.80 meters per second squared, and the initial velocity is 0. Common mistake is people would put this velocity in for the initial velocity in the y. All right, so now we're going to be solving for the time it takes to hit the ground. Okay, and the initial velocity is 0, so that part of the equation drops out. We're left with just this part of the equation. And solve for t. It comes out to be 14.6 seconds. Notice that two negatives cancel out, the one on the top and one on the bottom. If we would have counted this as being positive and this as being positive, in other words, counting down as positive, these two would have been positive, and it would have still come out to be 14.6 seconds. Okay? So this is to show you the idea that the horizontal speed has nothing at all to do with the time it takes to fall. All right. What are the magnitudes and directions of the final velocity of the same care package? Okay. Well, now we need to know both the x and the y final velocities. The x is not going to change. It stays 115 the whole time. But the y is constantly going to be changing. So what we need to do now is determine what the y velocity is. And we'll use our kinematic equations. Use the information we obtained from the previous problem. We need to find this final velocity. And using this equation, which you can easily see, we substituted the numbers. We came out to be a negative 143 meters per second. And why is it negative? Because we counted down as being negative and up as being positive. And if we use these numbers, negative 143 meters per second in the y and 115 meters per second in the x, we can easily find our final velocity and the angle. The final velocity would be using Pythagorean theorem, and the angle would be using the arctangent. All right. And I'm not going to go over that, but I think you guys all know how to do that. All right, let's try another example. Place kicker kicks a football at an angle of 40 degrees with an initial speed of 22 meters per second. Obviously, we're going to ignore air resistance again, and we want to determine the maximum height the ball obtains. Okay. All right, some things that we should understand. The maximum height, we do know some things about the maximum height. It's going to take half the time to go up and half the time to go down. We also know that on the top, the velocity in the y should be 0 because it has to stop going up before it can come back down. All right. Since the initial velocity was given and the angle was given, we're going to have to break it into components because they have to be treated independently of each other. Now, in reality, we don't really need the x direction for this problem, but I'm going to do it anyhow. So here is the equation for the y direction, and that would be the sine, because we know that sine of the angle is opposite over the hypotenuse, and we're solving for the opposite side. And there we have the adjacent side. and that would be using the cosine. All right. So in reality, at this particular problem, we don't need this 17 meters per second to find the maximum height. All right. So we're trying to find the maximum height. We know that gravity is 9.8 meters per second squared acting downwards. We know the final velocity in the y has to be 0 because it has to stop going up before we can come back down. And we know the initial velocity in the y is 14. The common mistake here would be people would put in 22 meters per second for this number, but that wouldn't be true because what you're actually trying to find is just the velocity initial in the y direction. And we don't know time, so we have to use this equation. All right. So we're going to solve this equation for y, and we come up with an answer of 10 meters. So that should take 10 meters to reach the top. All right. What is the time of flight between kickoff and landing? All right, so now we're looking at our picture again. We know that it takes half the time to go up and half the time to go down. We can do this a couple of different ways. We know the final velocity on top. We know the initial velocity down here in the y direction. We can use v final is equal to v initial plus at, solve for t, and then double it. Or we can take the idea that if this is the initial velocity in the y of 14 meters per second, when it gets down to here, it should be negative 14. So there's a couple different ways we can do it. All right, so there's our initial information. Okay, and here's a third way to do it. We can actually say to ourselves, well, what should the height be when it gets back down to the same height, or when it completes the arc, in other words? Well, the final distance or height should be 0 again. So that's a third way of doing it. All right. So now we put the initial velocity in the y times time plus 1/2 negative 9.80 meters per second squared times t squared. We could divide everything through by t and solve for t. And t actually has two answers. This equation would work like normal algebra, I guess, as 2.9 seconds when you solve it. But it would also work if the time was 0, which makes sense because that's where it was initially kicked. So the 2 times it should reach that height is where it was initially kicked. Right? Now let me go back so I can explain it better. The 2 times it would work is when the time is 0 here, it would be at that height, and 0 here, it would be at the height of 0 again. So that would be a time of 2.9 seconds and a time of 0 seconds, right? And as I said before, there's another way you could do it. We know that v final must be equal to the opposite of v initial in the y. So therefore we could also do it this way as well. We could take this equation and solve for t, just as I stated before. Okay? All right, let's try one more variant on this. Let's calculate the range of the projectile. What the range means is this distance here. Now this should be a really simple question when you think about it. If we know the total time it took to go up and back down, that's the same amount of time it took to go from here to here. So we know the total time to go up and back down is 2.9 seconds. All right? So to find the range, we can simply use this equation, where obviously that equation reduces back down to our simple equation, and put the answers in. Notice the velocity in the x doesn't change. So we took that velocity and we multiplied it by the total amount of time for the trip. The trip going up and back down. So while it was going up and back down, it also traveled 49 meters this direction. So hopefully these few examples showed you the independence of both the x and y direction.